y'all. So we're talking about 4.1a lesson, modeling equations. So module 4. This is the very beginnings, and this is a little bit lengthier of a lesson. It's got a lot of information, a lot of vocabulary. So important to understand as we move forward in this module. All right, identity properties. Identity properties. The word identity has to do with sameness. We use this word when we recognize the sameness between things. For example, you might say that a Halloween costume cannot really hide a person's true identity. Okay, earlier we defined the associative and commutative properties for both addition and multiplication. We need to do the same thing for the identity property. Okay, what do you think the identity property for addition should mean? Okay, so when you look at yourself in the mirror, you see yourself back. Okay, so identity is just exactly the same thing, what you see. Okay, so for addition, anything plus something equals the same anything. Okay, I know that sounds a bit vague with the anythings and the somethings, but hopefully this example will help you with that. So if we have like a 1 plus something and it stays equal to 1, what do you think that question mark would need to be? Okay, whoops, same thing with this one. -5 plus something equals that same number. What do you think that question mark would need to be? Okay. All right, so what do you think the identity property of multiplication should mean? Okay, so anything times something equals the same anything. Okay, so an example of that, 3 times something should give you that same 3 that you started with. Let me give you one more example. -4 times something should give you what you started with. All right, so hopefully you have in your mind what you would need to do with addition and what you would need to do for multiplication to get back the original thing. Okay, so let's put them down right here. So identity property of multiplication, anything times 1 equals anything. Okay, so multiplying anything by 1 won't change the expression. Okay, and then the identity property of addition, anything plus 0 won't change the expression. Did I say times? I meant add. Okay, adding 0 to anything won't change the expression. Okay, so those are 2 properties that you'll need to add to the list with commutative, associative, and substitution. Okay, now we've got identity of addition and identity of multiplication. All right, let's talk about inverse. Let me switch colors on inverse. Inverse properties. The word inverse means opposite or reverse. You might say forward is the inverse of backwards. There is an inverse for both addition and multiplication. Okay, what do you think the additive inverse of 3 would be? Hopefully you're thinking, oops, I gotta scooch that up. Hopefully you're thinking -3. What do you think the additive inverse of -3 would be? Hopefully you're thinking +3. Okay, so the inverse property of addition is this. Anything plus its opposite equals 0. Anything plus its opposite equals 0. Okay, what do you think the multiplicative inverse of 3 is? Okay, hopefully you're now switching your thought process to multiplication. Okay, 1/3 is that multiplicative inverse. We're going to take the reciprocal of 3 over 1. Okay, what do you think the multiplicative inverse of 1/3 is? Take the reciprocal of 1/3, which is 3. Okay, now the inverse property of multiplication states anything times its reciprocal is equal to 1. Let me get that out of the bottom there. Anything times its reciprocal is equal to 1. Okay, so let me write that in words. Anything times its reciprocal. Hopefully you remember what that is when we were dividing fractions. Remember, we always multiplied by the reciprocal. Okay, is 1. Okay, another 2 properties to add to the list. So we have commutative, we have associative, we have substitution. We just had identity of addition, identity of multiplication, because they're different. And then we just had inverse of addition and inverse of multiplication because they're different. Okay? All right, next property, multiplicative property of 0. Okay, that just states multiplying anything by 0 is 0. Okay, so the way that you'd see it in numbers and letters would be anything times 0 is 0. Okay, now let's start talking about solving equations. We're going to be using these properties in order to do so. Okay, what do you think it means to solve an equation? It just means to figure out the value of the variable in the equation. How does solving differ from simplifying? Okay, when you solve, you figure out the value, the variable, that's a letter, is equal to. It's a Q, period. Okay, when you simplify, you combine like terms. Okay, and you learned what like terms were in Module 3. You combine like terms and make the expression the smallest it can be. All right, now we're going to just do some examples of solving these equations. So we still have the same kind of key to represent the variables. Our x is going to be just a rectangle that's open, that's not shaded. Our negative x is going to be one that is shaded. And then we've got our 1 and our -1 as we've had for a couple modules now. I do tend to make circles instead of these squares just because they're quicker. Okay, but you can have your own system with these rectangles and squares. All right, let's get started. So we've got some number minus 1 equals 6. Write the algebraic procedure to solve, then check your answer. It's very important to make this statement. Everybody knows, I think, the answer is 7. Everybody knows 7 minus 1 equals 6. Okay, but we have to start as simple as possible. They don't get any easier than this. And we have to look at how we model them. Okay, so Here's how you start. Okay, now that we've got and we've been through module 3, we can now take a shortcut and model this as an x plus a negative 1. We all know for 2 modules now, this minus 1 means plus a negative 1. That's what that says, x plus negative 1. We've got our equals, and then we've got our 6 positive tiles. So here's our equation right here. This model matches this equation. Okay, now, what do we do first to get to, we want the object always is to get this x, 1x, all alone. Okay, hopefully you would say we need to get rid of this negative 1. The way to get rid of a negative 1 is to put a positive 1 over here and another positive 1 over here, because whatever you do on the left, you have to do on the right. Okay, so you always rewrite what you have. Always rewrite what you have. Okay, sorry that I went from square to circles. That's just quicker for circles. All right, so here's what I have. I just recopied. I recopied what was above. Okay, now I'm going to come in and I'm going to add, let me make this circular. This is bugging me. Okay, I'm going to add in a positive 1. If I do it to this side, I better do it to this side, which means I do it here and I do it here. Okay, I hope that you understand right here, this is the inverse. This is the inverse of addition. If you have a negative 1, the inverse of addition is a positive 1. That helped us solve this equation. Okay, so our answer, what's left over here? We have an x. What's left over here? 1, 2, 3, 4, 5, 6, 7. What does this come out to be algebraically? This side is an x. 6 plus 1 is a 7. This matches this. This matches this. Okay, now for the check. Okay, to check your answer, what you're going to do is you're going to take this equation, x minus 1 equals 6. Instead of the x, oops, I got to scooch that up. Take that equation. Instead of the x, put a parenthesis. Okay, and then we're going to take what we found x to be, 7 in this case, and plug it in. Is 7 minus 1 equal to 6? 7 minus 1 is 6, equal 6. So that checks out. Okay, 6 equals 6. All right, how did the first one go? It seems like a lot to do for a simple answer of 7, but we have to start simple. Remember, modeling is part of our 7th grade curriculum. Okay, it's part of our standards. It's not just Noonan being picky. This is something that the state says 7th graders should be able to do. Okay. All right, let's take a look at another one. All right, so we've got, let me stay with the same color theme here. X minus 3 equals positive 5. So remember from last module we learned, and the module before, a minus 3 is the same as plus a negative 3. This is the same thing as this. We used a shortcut. Okay, and then I've got my equal 5 positives. There it is. Okay, now my next step is always to write down exactly what I have. Okay, so I wrote down exactly what I have. Okay, so now I ask myself, my job is to get this 1x by itself. How do I get rid of a negative 3? Wouldn't I put a positive 3 in here? And if I put a positive 3 here, wouldn't I put a positive 3 over here? And wouldn't I put a positive 3 here and a positive 3 here? Okay, and again, I am using the inverse property of addition. in order to do that. That's the property I just learned that allows me to do that. All right, let's see what we have left over. 0 pairs. So I have my x equals 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. X equal 8. Okay, again, this step all matches the algebra, the model. This step all matches the algebra, the model. This step all matches the algebra, the model. Okay, now for the check. For the check, here's your original equation. In place of x, so I'm just rewriting the equation the way that it is, but instead of x, I'm putting a parenthesis. I'm going to tuck what my answer I found to be, and then I ask myself, what is 8 minus 3? 8 minus 3, so you handle everything kind of on this side, and then you handle everything on this side. So 8 minus 3 is 5. Is that equal to 5? Yes, it is. Okay, and again, probably from second grade, if someone asks you, what minus 3 would get you 5? You know that's 8 right away. But we have to start really easy to understand this modeling process. Okay, number 3. Okay, don't be alarmed if it kind of looks backwards. 8 equals 7 plus m. Okay, now notice our first step is not given. So we're doing the whole thing ourselves. Okay, so I've got 8. 1, 2, 3, 4, 5, 6, 7, 8 equals 1, 2, 3, 4, 5, 6, 7, and an m. Okay, that x tile could be any letter. Usually it's an x, but it could be an m. It could be any letter. Okay, in this case, it's an m. All right, so we've got 8 equals 7 plus m. We know from second grade, 7 plus 1 is going to get us 8. We know the answer is going to be 1, but it's about this modeling process. All right, so your first step is draw what the numbers and letters represents with tiles. Okay, your second step has always been copy what you have here. 1, 2, 3, 4, 5, 6, 7, 8 equal 1, 2, 3, 4, 5, 6, 7, and an m. So I copied exactly what I have. And then I ask myself, if I want to get m alone, how do I get rid of 7 positives? I get rid of 7 positives by bringing on 7 negatives here. 2, 3, 4, 5, 6, 7. If I bring on 7 negatives here, I have to bring on 7 negatives on the other side. 1, 2, 3, 4, 5, 6, 7. Perfect. Okay, so don't I bring on 7 negatives on both sides here also? Okay, so again, that whole step matches. Now I see what's left. Okay, I've got an m left on this side. That's exactly what I wanted. Look at all these 0 pairs. I just have 1 chip. Okay, let's look over here. 8 minus 7, that's 1, equal, this would be m. Okay, let's do the check. The check, I'm going to rewrite 8 equals 7 plus m. Instead of the m, I've got some parentheses. Tuck in your answer 1 in place of the m. We're substituting that 1 in for m. Okay, now this side's 8. This side, 7 plus 1 is 8. Does 8 equal 8? Yes, it does, so I must have done the problem correctly. Okay, now up over here, again, this was done by the inverse property of addition. Looking at problems 1 through 3 in general property allows you to isolate the variable. This word isolate just means get the letter alone. That's what isolate means. Okay, if you're isolated, you're alone. Okay, so this is the inverse property of addition. Okay. All righty, so that is adding and subtracting. Now we're going to get on to some multiplying. All right, 6 equals 3x. All right, I could put 6 like this and 3x is like this, but I want to try to think in stacks this way. Okay, so what would happen if I did my 3x's like this? And how could I arrange my 6 tiles into these kind of 3 lines? Hopefully you're thinking 2, 2, 2. Okay, isn't this 6 equal 3x? Okay, so that's the original question. Okay, second step was always to rewrite that original model. There it is. Okay, now I'm asking myself, what do I need to do to get 1x? Right now I have 3 x's with multiplication. Does everybody see that I could take a third of this picture? Couldn't I take thirds? Couldn't I take a third? Well, if I take a third of this picture, wouldn't I be left with this? X equal 2. If I take a third of 6, I'd have 2. If I take a third of 3x, I'd have x. There's my answer, x equal 2. Okay, so let's go ahead and do a check. 6 equal 3x, 6 equal 3 parentheses. 2 I found is my answer for x. So instead of x, I'm putting in a 2. Let's see if this makes sense. This side is 6. This side is 6. Does 6 equal 6? Yes, it does. Okay, and again, from third grade, second grade, you know 3 times 2 equals 6. But it's about this process. You have to buy into chips now. And don't just be thinking 2, because this is going to be worth lots of points on a quiz or a test for the modeling part. Please do not discount it. Okay. All right, number 6. First time we're seeing a negative with a variable. All right, we've got 8 and we've got negative 2m. All right, I'm going to think about my negative 2m like that. Now 8, I want to try to do 2 rows. So I'm going to do 4, 1, 2, 3, 4, and 4. Okay, so this is 8 equal negative 2m. I have just modeled the problem that was given. All right, so I want to think about how I can get one of these alone. Do you see that I could take and think of this picture in halves? Take half of it. Oopsies, you know what I did? Scratch that. Okay, I needed to recopy 2, 3, 4. Sorry, 1, 2, 3, 4. I was jumping the gun on that, skipping a step. Okay, oops on the green. Sorry, ignore the green. Okay, so I'm recopying. Second step is always to recopy. Okay, now I'm asking myself, what do I need to do to get one of these? Okay, I'm going to think about cutting this thing in half. Cutting this thing in half. All right, if I cut this picture in half, wouldn't I have a negative m equal to 1, 2, 3, 4 chips? Wouldn't this be 4? Half of 8 is 4. And then half of this would be negative 1m. Okay, isn't this exactly what this is? Last step, you can never have a negative variable in your final answer. You can never have a negative variable. So we would just flip this over to be positive and flip these over to be positive. Okay, let me show you with these chips. I'd have 1, 2, 3, 3, 4. Okay, that's what I have right now. Move this paper. That's what I have right now. M equal 4 positives. Well, if I come in here and take the opposite of all this, multiply all this by a -1, wouldn't I have positive M and 4 negatives? Okay, so this would be a positive M equal 4 negatives. All right, now the check. 8 equal -2 M. 8 equal -2 parentheses. We're going to put a -4 in there. Okay, the left side obviously is 8. And this right side, -2 times -4, positive 8. 8 equal 8, it checks out. Okay, now it's very important to think about what property allows this green step. Okay, hopefully you guys are thinking the inverse of multiplication. Okay, same with this one down here. Okay, to get rid of a 3x, we would multiply the 3 times a third to get 1x. That's what we learned when we went over the properties at the beginning. Inverse of multiplication. Okay. All right. Next. All right, we've got another multiplication problem. If you want to pause it and try it on your own, go for it. All right, so 3 x's. 1, 2, 3, -6. I want to think of 3 rows like this. So I'm going to think of 2, 4, 6. So I've got 3x equal -6. Recopy. I didn't get ahead of myself this time. Recopy the problem. All right, what do I need to do to get 1x? Right now I have 3 x's, so hopefully you're thinking I need to look at this thing in thirds. I need to look at this thing in thirds. Okay, so if I look at this in thirds, I'd have an x. If I look at this in thirds, I'd have 2 negatives. If I look at this in thirds, I use my inverse of multiplication to get my x. A third of this is -2. So again, I use the inverse of multiplication in order to get that. Okay, let's check our answer. 3x equal -6. 3 parentheses equals -6. -2 goes in the parenthesis. What's 3 times -2? -6. And this -6 is just hanging out as a -6. -6, yes, in fact, equals -6. All right, the last type, division. We've got division. All right, now this x, we can't break it into a third of this. Okay, so, and it's very important for me to point out this concept right here. X over 3 is the same thing as 1/3 x. This is very, very important to understand. X over 3 is the same thing as 1/3 of an x. Means the same thing. All right, so if I have an x and I break it up into a third, that's how I would show a third of an x equals 2 negatives. So I have x over 3 equals -2. So that's my original equation modeled. All right, I want a full x. If I have a third, don't I have to triple this picture? Wouldn't I have to triple this picture? 1, 2, 3. So there's that picture tripled. And then here's this side tripled. And then here's this thing tripled. All right. 1/3, 1/3, 1/3 makes a full x equals 6 negatives. 1, 2, 3, 4, 5, 6. So if we have a third x and we multiply it by 3, again, we're using that inverse of multiplication. That would just be a plain old x, and 3 times -2 is -6. Doesn't look like a -6. There we go. All right, check in this answer. Check. X over 3 equals -2. This time I've got parentheses over 3 equal -2. I'm going to tuck in this -6 up here. What's -6 divided by 3? -2. Bring down this -2. Is -2 equal to -2? Yes, sirree, Bob. Okay. All right. We've got one more. One more, and then there's a page that nutshells all the properties that we've done today that I'm not going to go through, but you have a printed, what's it called, like a sheet that has all the answers on it underneath one of the PDFs that's posted on Google Classroom. Please access that. Okay. Copy it on your own or print it so you have all of them on one piece of paper. Okay. So again, this 1/2 x, it's very important to understand that these mean the same thing. Those mean the same thing. 1/2 x equals x over 2. All right, so again, you can't take this little dealy-mabob and break it. So the way that we show that on paper is by this. All right, what do I need to do to get a full x? To get a full x, wouldn't I need to do 2 of these 1/2 x's? Okay, and wouldn't I need to do 2 of that? Okay, so I've got, this makes a full x equal to 6 chips. 1, 2, 3, 4, 5, 6. 1/2 x times 2 by the inverse of multiplication is an x. 3 times 2 is 6. So again, this model step always matches the algebraic step next to it. Okay, let's check our answer. Check. 1/2 x equal 3. 1/2 parentheses equal 3. Instead of the parentheses, we're going to tuck in a 6. What's 1/2 of 6? 1/2 of 6 is 3. This 3 carries down. 3 equal 3? It sure does. Okay, what property on the last handful that we've done, numbers 5 through 9, allowed me to isolate? Again, isolate means get the X or M or whatever letter it is all alone. Okay, this would be the inverse property of multiplication. Okay, and then you guys, there is another page if you're looking at the blank PDF, and it's got the identity property of addition, multiplication, multiplicative property of 0, and both inverse properties. If you want it all on one piece of paper, the answers to that are in the other PDF that's not blank, that's in the same post. Okay, so you can either print that page or you can just copy down the boxes that I don't have things in from that answer sheet. Okay, I don't think I need to take the time to re-go over this. Okay, it's just if you want it on one piece of paper. Okay. All right, sorry this was a little bit longer than usual. It was a big lesson, a very important lesson, just starting the solving of equations. Okay, thanks guys.